Right now, somewhere in the world, a fighter jet is breaking the sound barrier at twice the speed of sound, carrying weapons that could level city blocks. These aren't just machines, they're the apex predators of the sky, engineered to dominate airspace and project power across continents. From Cold War legends that terrorized enemies to modern stealth fighters that appear invisible to radar, today we're counting down the 10 most legendary fighter jets that didn't just change warfare. They rewrote the rules of what's possible in the sky. McDonnell Douglas F-4 Phantom II. The F-4 Phantom II holds a record that no other American fighter will ever match. 5,195 aircraft built, making it the most produced supersonic military aircraft in U.S. history. This twin-engine beast could carry over 18,000 pounds of weapons while screaming through the sky at Mach 2.2, but what made it truly legendary wasn't just its raw power. During the Vietnam War, the Phantom proved that brute force could overcome elegant design. It was big, it was ugly, and it smoked like a freight train, earning the nickname Double Ugly. But when North Vietnamese MiG-21S tried to challenge American air superiority, the F-4 responded with devastating effectiveness. All 5 American servicemen who became aces during Vietnam did so flying Phantoms. The aircraft's versatility was unmatched for its era. It could intercept Soviet bombers at high altitude, deliver nuclear weapons deep into enemy territory, or provide close air support for ground troops. Its twin-seat configuration allowed for a pilot and weapons systems officer, creating a deadly team that could manage complex missions while maintaining situational awareness. What truly set the Phantom apart was its adaptability. Initially designed without an internal cannon, later variants incorporated the M61 Vulcan rotary cannon when combat experience showed the need for close-range firepower. The F-4 served with 11 countries and remained in frontline service for over 3 decades, proving that sometimes the most successful fighter isn't the prettiest. It's the one that gets the job done. Mikoyan-Gurevich MiG-21. More than 10,000 MiG-21AS have been built since 1955, making it the most produced supersonic fighter in aviation history. This Soviet interceptor, codenamed Fishbed by NATO, became the backbone of air forces in over 60 countries and still flies today, 7 decades after its first flight. The MiG-21's design philosophy was brutally simple: create the smallest, lightest airframe possible around the most powerful engine available. The result was a fighter that could climb at 46,250 feet per minute and reach Mach 2.05, performance that rivaled much larger and more expensive Western fighters. Its delta wing configuration made it incredibly fast in a straight line, though it bled energy quickly in turning fights. In Vietnam, the MiG-21 became the F-4 Phantom's most dangerous adversary. While American pilots had superior training and equipment, the MiG-21's small size and agility made it a formidable opponent in close combat. North Vietnamese pilots shot down approximately 50 American aircraft with MiG-21S, though they lost 68 of their own in return. The aircraft's true genius lay in its simplicity and reliability. Unlike complex Western fighters that required extensive maintenance, the MiG-21 could operate from rough airstrips with minimal ground support. Its Tumansky engine featured an emergency power mode that could boost thrust to over 21,000 pounds for 2 minutes, giving pilots a crucial advantage when they needed it most. This combination of performance, reliability, and affordability made the MiG-21 the AK-47 of fighter jets: simple, effective, and everywhere. McDonnell Douglas FA-18 Hornet. The FA-18 Hornet revolutionized naval aviation by becoming the world's first true multi-role fighter, capable of switching between air-to-air and air-to-ground missions during the same flight. This twin-engine marvel entered service in 1983 and immediately proved that versatility could be just as valuable as raw performance. During Operation Desert Storm, Hornets demonstrated their unique capabilities by shooting down enemy fighters and bombing ground targets within the same mission. This flexibility allowed carrier air wings to adapt to changing tactical situations without requiring different aircraft for different roles. The Hornet's robust design meant it could take direct hits from surface-to-air missiles, return to the carrier, be repaired overnight, and fly again the next day. What made the Hornet truly special was its pilot-friendly design. The aircraft featured advanced fly-by-wire controls that made it nearly impossible to stall or lose control, even in extreme combat maneuvers. Its twin-engine configuration provided redundancy crucial for carrier operations, where a single engine failure over the ocean could be fatal. The Hornet's carrier capabilities were equally impressive. It could operate from World War II-era carriers with limited deck space as well as modern supercarriers, making it incredibly versatile for naval operations. Its stable landing approach and excellent low-speed handling characteristics made carrier landings safer and more predictable than previous naval fighters. The FA-18 became the workhorse of both Navy and Marine Corps aviation, serving as the primary bridge platform until the F-35's arrival, proving that sometimes the best fighter is the one that can do everything well. General Dynamics F-16 Fighting Falcon. Over 4,600 F-16 Fighting Falcons have been built since 1976, making it honestly one of the most successful fighter aircraft in history. This single-engine lightweight fighter really proved that bigger isn't always better, combining exceptional maneuverability with cutting-edge technology in a package that dozens of countries could actually afford. The F-16's revolutionary design centered around one key innovation: fly-by-wire flight controls. This computer-controlled system allowed the aircraft to be inherently unstable, meaning it actually wanted to tumble out of control. While that sounds dangerous, it actually made the F-16 incredibly maneuverable, able to change direction faster than any previous fighter. The pilot sits in a reclined position under a bubble canopy that provides 360-degree visibility, which is just crucial for spotting threats in air-to-air combat. In combat, the F-16 has proven itself over and over again. Israeli F-16S destroyed Iraq's nuclear reactor in 1981, flying a precision strike mission that required perfect navigation and timing. During the Gulf War, F-16S flew more sorties than any other coalition aircraft, really demonstrating their reliability and versatility in both air-to-air and air-to-ground roles. The Fighting Falcon's success comes from its balance of performance, reliability, and cost-effectiveness. It can pull 9 Gs in combat maneuvers, reach Mach 2, and carry a variety of weapons, all while remaining affordable enough for smaller air forces to operate. This combination has made the F-16 the backbone of NATO air power and, honestly, the standard by which all other lightweight fighters are measured. It just goes to show that sometimes the most successful design is the one that gets the fundamentals exactly right. McDonnell Douglas F-15 Eagle. The F-15 Eagle holds the most impressive combat record of any modern fighter: 104 air-to-air victories with 0 losses in aerial combat. This twin-engine air superiority fighter was designed with one mission in mind: to dominate the skies against any opponent, anywhere in the world. When the F-15 first flew in 1972, it represented a quantum leap in fighter technology. Its twin Pratt and Whitney engines produced enough thrust to accelerate the aircraft straight up like a rocket, while its advanced radar could track multiple targets simultaneously at ranges exceeding 100 miles. The combination of raw power and sophisticated sensors made the Eagle nearly invincible in air-to-air combat. The F-15's combat debut came with the Israeli Air Force in 1979, where it quickly established air superiority over Lebanon. During the 1982 Lebanon War, Israeli F-15S shot down 40 Syrian aircraft without losing a single Eagle. This pattern repeated in every conflict where F-15S participated: Gulf War, Bosnia, Iraq. The Eagle consistently dominated enemy fighters. What makes the F-15 truly remarkable is its longevity. Despite being designed in the 1960s, continuous upgrades have kept it relevant against modern threats. The latest F-15EX variant incorporates advanced radar, digital fly-by-wire controls, and can carry up to 22 air-to-air missiles, more than any other fighter in production. The Eagle's success formula is simple: overwhelming power, superior sensors, and pilot-friendly design. It really proves that when you build a fighter to be the absolute best at air-to-air combat, that superiority can last for decades. Sukhoi Su-27 Flanker. The Su-27 Flanker was the Soviet Union's answer to the F-15 Eagle, and in many ways it actually exceeded its American rival's capabilities. This massive twin-engine fighter combined incredible range, heavy armament, and super maneuverability in a package that could patrol the vast expanses of Soviet airspace. At 72 feet long with a 48-foot wingspan, the Su-27 is one of the largest fighters ever built, but its size really serves a purpose. Internal fuel capacity of over 20,000 pounds gives it a combat radius exceeding 1,000 miles. allowing it to escort bombers deep into enemy territory or patrol remote borders without refueling. Its twin AL-31F engines produce 27,600 pounds of thrust each, giving the massive fighter a thrust-to-weight ratio that enables vertical climbs and incredible acceleration. The flanker's party trick is its super maneuverability. The aircraft can perform the Cobra maneuver where it suddenly pitches its nose up to 90 degrees while maintaining forward momentum, then snaps back to level flight. This extreme maneuver can cause pursuing fighters to overshoot, giving the Su-27 a tactical advantage in close combat. In combat, the Su-27 has proven its worth. During the Eritrean-Ethiopian War, Ethiopian Su-27S shot down 5 Eritrean MiG-29S, demonstrating the flanker's superiority even over other advanced Soviet fighters. The aircraft's sophisticated radar can track 10 targets simultaneously while engaging 4, making it a formidable opponent in beyond visual range combat. The Su-27's influence extends far beyond Russia, spawning variants like the Su-30, Su-33, and Su-35, proving that sometimes the best response to a great fighter is an even greater one. Lockheed Martin F-22 Raptor. So, the F-22 Raptor represents the pinnacle of fighter aircraft technology. It's a fifth-generation stealth fighter that, honestly, combines invisibility, supercruise, and super maneuverability in ways that no other aircraft can really match. Only 187 operational Raptors were built, making it the most exclusive fighter jet in the world. The Raptor's stealth technology makes it, well, virtually invisible to enemy radar. Its angular surfaces and special coatings reduce its radar signature to that of a marble, which allows it to penetrate enemy airspace undetected. But you know, stealth is just one part of the equation. The F-22 can supercruise, meaning it can fly faster than sound without using afterburners, giving it the ability to dash between targets while conserving fuel and maintaining stealth. In air-to-air combat, the F-22 is simply unmatched. Its AN/APG-77 radar can track multiple targets at extreme ranges while, impressively, remaining undetected itself. The aircraft carries 6 AIM-120 AMRAAM missiles internally, allowing it to engage multiple targets simultaneously. Its thrust vectoring engines enable maneuvers that, honestly, defy physics, including the ability to point its nose in directions its body isn't even traveling. The Raptor's combat record, while limited, is perfect. During operations in Syria, F-22S provided air superiority while remaining completely undetected by enemy forces. The aircraft's mere presence in a combat zone forces enemies to alter their tactics, knowing they face an opponent they cannot see or effectively engage. At $150 million per aircraft, the F-22 is the most expensive fighter ever built, but it represents a level of technological superiority that, honestly, may not be matched for decades. Dassault Rafale. The Dassault Rafale proves that sometimes the best fighter comes from going it alone. When France withdrew from the Eurofighter program in the 1980s, they created something uniquely French, an omnirole fighter that could excel in every mission from air superiority to nuclear strike. The Rafale's twin-engine Canard Delta design gives it exceptional agility while maintaining stability across all flight regimes. Its Spectra electronic warfare system provides 360-degree threat detection and countermeasures, while the RBE-2 AESA radar can track 40 targets simultaneously. This sensor fusion creates a level of situational awareness that few fighters can match. In 2009, a Rafale achieved something remarkable. It shot down an F-22 Raptor in a training exercise. While the engagement occurred under specific conditions that favored the Rafale, it demonstrated that even the world's most advanced stealth fighter isn't invincible against a well-flown conventional aircraft with superior sensors and weapons. The Rafale's combat record spans from Afghanistan to Libya to Mali, where it has consistently delivered precision strikes while maintaining air superiority. Its ability to operate from both land bases and aircraft carriers makes it uniquely versatile among modern fighters. The aircraft can carry up to 21,000 pounds of weapons across 14 hardpoints, including the Scalp cruise missile for long-range precision strikes. What sets the Rafale apart is its integration of French technology throughout. From its SNECMA engines to its Thales radar, the Rafale represents complete technological sovereignty, proving that innovation doesn't require international cooperation. Sometimes it requires the courage to go your own way. Eurofighter Typhoon. The Eurofighter Typhoon represents the pinnacle of European aerospace cooperation, combining the expertise of Britain, Germany, Italy, and Spain into a fighter that excels in both air-to-air and air-to-ground missions. This twin-engine Canard Delta fighter proves that international collaboration can produce world-class military technology. The Typhoon's design prioritizes agility above all else. Its Canard Delta configuration and powerful EJ-200 engines give it a thrust-to-weight ratio that enables sustained vertical climbs and turn rates that consistently outperform competitors in training exercises. The aircraft can supercruise at Mach 1.5 without afterburners, giving it the ability to dash between targets while conserving fuel. In combat, the Typhoon has proven its worth over Libya, where it flew both air-to-air patrols and precision ground strikes. Its Captor-E-ISA radar provides exceptional detection capabilities, while the Pirate infrared search and track system allows for passive target detection. The integration of Meteor beyond visual range missiles gives the Typhoon one of the longest engagement ranges of any fighter. What makes the Typhoon unique is its swing roll capability, the ability to switch between air-to-air and air-to-ground missions during the same flight. A Typhoon can begin a mission configured for air superiority, engage enemy fighters, then immediately transition to ground attack mode to strike surface targets, all while maintaining full defensive capabilities. With over 720 aircraft ordered by 9 countries, the Typhoon has become Europe's premier fighter, proving that when nations combine their technological expertise, they can create aircraft that rival anything produced by traditional aerospace superpowers. Grumman F-14 Tomcat. The F-14 Tomcat was the ultimate interceptor, designed to protect U.S. Navy carrier battle groups from Soviet bomber attacks during the Cold War. This twin-engine, variable sweep wing fighter could engage multiple targets at ranges exceeding 100 miles, making it the guardian of the fleet for over 3 decades. The Tomcat's most distinctive feature was its variable sweep wings, which could adjust from 20 to 68 degrees depending on flight conditions. This gave the F-14 exceptional performance across all speed ranges, efficient cruise flight with wings swept forward, and high-speed dash capability with wings swept back. Combined with its powerful twin engines, this made the Tomcat one of the fastest fighters ever built, capable of exceeding Mach 2.3. The F-14's weapons system was revolutionary. Its AWG-9 radar could track 24 targets simultaneously while engaging 6 with AIM-54 Phoenix missiles. These massive missiles had a range of over 100 miles and could destroy targets the size of bombers at extreme distances. No other fighter could match this long-range intercept capability. In combat, the Tomcat proved its worth during the 1980s confrontations with Libya, where F-14s shot down Libyan fighters in several engagements. The aircraft's combination of speed, range, and powerful radar made it nearly invincible in air-to-air combat when flown by skilled crews. The F-14's legacy extends beyond combat effectiveness. Its starring role in Top Gun made it the most recognizable fighter jet in popular culture, inspiring generations of pilots and aviation enthusiasts. When the last Tomcat retired in 2006, it marked the end of an era in naval aviation. From the Phantom's brute force to the Raptor's technological supremacy, these 10 fighters didn't just dominate their eras. They defined what air power means in the modern world. Each aircraft pushed the boundaries of what was possible, whether through raw performance, innovative design, or revolutionary technology. As we look toward the future with 6th-generation fighters on the horizon, these legends remind us that the greatest aircraft aren't just machines. They're the result of human ingenuity, engineering excellence, and the relentless pursuit of air superiority. Thanks for watching Stellar Tech, and don't forget to subscribe for more incredible stories from the world of aviation and technology. What if I told you that in 2017, something from another star system visited our solar system, and one of Harvard's top scientists believes it might have been sending us a message? Oumuamua, the first confirmed interstellar visitor, has sparked the most controversial debate in modern astronomy. When Joe Rogan sat down with physicist Avi Loeb, the conversation revealed shocking theories that challenge everything we thought we knew about our cosmic neighborhood. Today, we're diving deep into the mystery that has scientists questioning whether we've already encountered alien technology. The discovery that changed everything. October 19, 2017, marked a historic moment that most people completely missed. On that day, astronomers at the Pan-STARRS telescope in Hawaii detected something that shouldn't exist, an object moving through our solar system at impossible speeds, following a trajectory that proved it came from another star system. Named Oumuamua, meaning messenger from afar arriving first in Hawaiian, this mysterious visitor was unlike anything scientists had ever encountered. The object was traveling at 196,000 miles per hour, far too fast to be captured by our sun's gravity. Its hyperbolic trajectory confirmed what seemed impossible. We were witnessing humanity's first confirmed interstellar visitor. What made this discovery truly extraordinary wasn't just its origin but its timing. Astronomers estimate that interstellar objects like Oumuamua pass through our solar system about once per year, but they're typically too faint and fast to detect. Only recently had our telescopes become powerful enough to spot such visitors. The fact that we caught this one suggested either incredible luck or that these objects might be more common than previously thought. Within days of its discovery, Oumuamua would reveal characteristics that would divide the scientific community and spark debates that continue today. An object unlike anything we've seen. The more scientists studied Oumuamua, the stranger it became. This wasn't just another space rock. It was something that defied every category astronomers had for celestial objects. The object's shape was the first major anomaly. Based on how its brightness changed as it tumbled through space, scientists calculated that Oumuamua was extremely elongated, roughly 10 times longer than it was wide. To put this in perspective, imagine a cigar that's 1,300 feet long but only 130 feet wide. No asteroid or comet in our solar system has ever been observed with such an extreme aspect ratio. Even more puzzling was its behavior. As Oumuamua rotated every 7.3 hours, its brightness varied by a factor of 10, the most dramatic brightness variation ever recorded for a natural space object. This suggested either an incredibly unusual shape or surface properties unlike anything in our cosmic neighborhood. The object's reddish color, similar to objects in the outer solar system, indicated it had been wandering through interstellar space for hundreds of millions of years, its surface reddened by cosmic radiation. Yet despite this ancient journey, Oumuamua showed no signs of the dust or gas emissions typical of comets when they approach the sun. The acceleration mystery that baffled scientists. Just when astronomers thought they understood Oumuamua, the object delivered its most shocking surprise. It was accelerating away from the sun in a way that gravity alone couldn't explain. This non-gravitational acceleration was subtle but unmistakable. As Oumuamua sped away from our solar system, it was moving faster than it should have been based purely on gravitational calculations. For comets, this kind of acceleration is normal. Ice vaporizing from their surface creates a rocket-like effect, but Oumuamua showed absolutely no signs of cometary activity. The acceleration was consistent and measurable, ruling out random forces or measurement errors. Something was pushing Oumuamua, but what? Traditional explanations fell short. The object was too small for solar radiation pressure to account for the observed acceleration, and it lacked the outgassing that typically propels comets. This mysterious acceleration became the smoking gun that would fuel the most controversial theory in modern astronomy. If natural explanations couldn't account for Oumuamua's behavior, what could? The answer would come from an unexpected source, Harvard's Department of Astronomy, where one physicist was willing to consider possibilities that others dismissed as impossible. The stage was set for a scientific revolution that would challenge our understanding of our place in the universe. Avi Loeb's revolutionary theory shakes science. When Harvard physicist Avi Loeb appeared on Joe Rogan's podcast, he dropped a bombshell that sent shockwaves through the scientific community. Oumuamua might be artificial technology from an alien civilization. Loeb, former chair of Harvard's astronomy department, wasn't some fringe theorist. He was a respected scientist with hundreds of published papers, who had simply followed the evidence to its logical conclusion. Just like Sherlock Holmes, I follow the evidence, trying to find the solution. The physicist's theory centered on one key insight. Oumuamua's unusual properties perfectly matched what engineers would design for an interstellar light sail. Its extreme thinness would minimize damage from interstellar dust, while its flat geometry would maximize surface area for solar radiation pressure. exactly what would propel a light sail through space. Loeb's calculations showed that solar radiation pressure could indeed account for Oumuamua's mysterious acceleration, but only if the object was incredibly thin, like a sheet of paper tumbling through space. This wasn't just speculation, it was based on rigorous physics and observations that other natural explanations couldn't adequately address. The scientific establishment's reaction was swift and harsh, but Loeb stood firm in his assessment.
The light sail theory that changes everything.
The concept that Oumuamua could be an alien light sail isn't science fiction, it's cutting-edge physics that we're already developing here on Earth. Light sails work on a simple principle. Photons from stars carry momentum that can push extremely thin reflective surfaces. Just as wind pushes a ship's sail, starlight can propel a spacecraft equipped with a large, lightweight sail. The technology is so promising that organizations like Breakthrough Starshot are developing light sail probes to reach nearby star systems. Oumuamua's behavior perfectly matched what scientists would expect from a light sail. Its acceleration was consistent with solar radiation pressure acting on a thin, flat object. The lack of outgassing made sense because artificial objects wouldn't contain volatile materials that vaporize near the sun. Even its tumbling motion resembled how a damaged or derelict light sail might behave after millions of years in space. Maybe it was just alien craft technology that unintentionally lost itself, like space junk. Loeb suggested, making the theory seem less threatening and more plausible. The search for alien signals begins. The possibility that Oumuamua might be artificial technology triggered the most intensive search for alien signals in modern history. Breakthrough. Listen, the world's most comprehensive SETI program immediately turned the massive Green Bank telescope toward Oumuamua. If the object was indeed artificial, it might be transmitting signals, either intentionally or as electromagnetic leakage from its systems. The search was unprecedented in its scope and sensitivity. Over multiple observation sessions, the telescope scanned billions of radio frequencies, recording a staggering 90 terabytes of data, enough to fill 23 high-end computers. The observations covered different phases of Oumuamua's rotation, ensuring that any potential signals from different parts of the object would be detected. The sensitivity was remarkable. At Oumuamua's distance, the telescope could have detected a signal as weak as a cell phone transmission. If alien technology was aboard this mysterious visitor, we would have heard it. The results were both disappointing and reassuring. No artificial signals were detected from Oumuamua. The object remained silent as it tumbled through space, offering no direct evidence of alien technology. However, the absence of signals didn't disprove the artificial hypothesis. A derelict piece of technology wouldn't necessarily be transmitting.
Why natural explanations fall short.
The scientific community's resistance to Loeb's alien hypothesis led to, well, increasingly creative attempts to explain Oumuamua through natural processes, but each explanation just seemed to create new problems. One theory suggested that Oumuamua was a hydrogen iceberg, basically a chunk of solid hydrogen that would sublimate near the sun, causing the observed acceleration. But, solid hydrogen couldn't actually survive the millions of years needed for interstellar travel, and the object didn't show any of the expected hydrogen emissions. Another proposal claimed Oumuamua was a fragment of a disrupted comet, but this idea couldn't account for its extreme elongation or the lack of any cometary activity. Some scientists even suggested it was a dust bunny, meaning a loosely bound collection of particles, but an object like that would have been torn apart by tidal forces during its close approach to the sun. The most recent theory proposed that Oumuamua was made of nitrogen ice, kind of like Pluto's surface. While this could maybe explain some of the observations, it would require the object to have originated from a Pluto-like world in another star system, which is, honestly, itself a pretty extraordinary claim. So, each natural explanation required increasingly exotic conditions or materials, leading some scientists to start questioning whether the artificial hypothesis might actually be the simpler explanation. The implications of alien technology. If Oumuamua truly represents alien technology, the implications for humanity are, honestly, staggering, and fundamentally change our understanding of our place in the universe. The object's properties suggest it wasn't sent to spy on Earth or, make contact. Its trajectory showed no signs of course corrections toward our planet, and it was already leaving the solar system when we discovered it. This supports Loeb's theory that we encountered cosmic debris, the equivalent of finding a piece of alien trash just floating through space. Strangely enough, this scenario might actually be more significant than active alien contact. It suggests that technological civilizations are common enough that their artifacts regularly drift through the galaxy. If Oumuamua is artificial, it implies that advanced civilizations have been building interstellar technology for, well, millions of years, leaving a trail of debris in their wake. The discovery would also validate humanity's own technological trajectory. We're developing light sail technology for interstellar exploration, which suggests that this approach represents a natural evolutionary step for spacefaring civilizations. Oumuamua might be showing us our own future, a time when human-built light sails will traverse the galaxy, potentially becoming mysterious visitors to other star systems.
The race against time and distance.
One of the most frustrating aspects of the Oumuamua mystery was just how quickly the opportunity to study it disappeared, highlighting the challenges of investigating interstellar visitors. By the time scientists realized Oumuamua's true significance, it was already racing away from the sun at, honestly, incredible speed. The object was moving so fast that no existing spacecraft could catch up to it for a closer look. Even our most powerful rockets would have taken decades to reach Oumuamua, and by then it would be way too far away to study effectively. This time, pressure forced astronomers to make critical observations with ground-based telescopes while the object was still detectable. Every day that passed meant Oumuamua was getting fainter and harder to observe. The window for detailed study lasted only a few months before the object became too distant for meaningful analysis. The experience taught scientists some valuable lessons about preparing for future interstellar visitors. New detection systems are being developed to spot such objects earlier, giving researchers more time to study them. Space agencies are also considering rapid response missions that could be launched quickly to intercept future visitors before they escape our solar system.
What Oumuamua means for the future.
Oumuamua's brief visit has, without a doubt, fundamentally changed how we think about interstellar space and our search for extraterrestrial intelligence, regardless of whether it was natural or artificial. The object proved that interstellar visitors are detectable with current technology, opening a whole new field of astronomy. Scientists now know what to look for and have developed protocols for studying future visitors more effectively. The recent discovery of additional interstellar objects, including Comet 2I Borisov and the newly detected 3I Atlas, shows that Oumuamua wasn't a unique event. If Oumuamua was indeed artificial, it suggests that the galaxy might be filled with technological artifacts from ancient civilizations. This archaeology of the galaxy approach to SETI represents a new way of searching for evidence of alien intelligence, not through radio signals, but through physical artifacts drifting through space. The controversy surrounding Oumuamua has also highlighted the importance of keeping an open mind in science. Loeb's willingness to consider unconventional explanations, despite professional criticism, really demonstrates the value of following evidence wherever it leads. As we continue to develop our own interstellar technology, Oumuamua serves as a reminder that we might not be alone in this cosmic endeavor. From its mysterious acceleration to its impossible shape, Oumuamua challenged everything we thought we knew about our cosmic neighborhood. Whether it was a natural phenomenon or humanity's first encounter with alien technology, this interstellar visitor opened our eyes to possibilities we never imagined. As Joe Rogan and Avi Loeb showed us, sometimes the most extraordinary explanations deserve serious consideration. The truth about Oumuamua may remain a mystery, but its impact on science and our understanding of the universe will last forever. Thanks for watching Stellar Tech, and don't forget to subscribe for more cosmic mysteries. Imagine a moment when humanity's most powerful machine briefly created a microscopic black hole, a tiny tear in the fabric of space-time itself. This happened not in some distant galaxy but right here on Earth, deep beneath the Swiss-French border at CERN's Large Hadron Collider. In recent years, scientists have observed phenomena that could represent the birth and evaporation of micro-black holes, discoveries that challenge our understanding of physics, extra dimensions, and the very nature of reality. Today we dive into what happened after CERN scientists created these quantum black holes.
The machine that recreates the Big Bang.
The Large Hadron Collider at CERN stands as humanity's most ambitious scientific instrument. a 27-kilometer ring of superconducting magnets buried 175 meters beneath the France-Switzerland border near Geneva. Built between 1998 and 2008 through collaboration with over 10,000 scientists from hundreds of universities across more than 100 countries, the LHC represents the pinnacle of human engineering achievement. This massive machine accelerates protons to 99.9999991% of light speed, creating collision energies of up to 13 tera-electron-volts, conditions that haven't existed in our corner of the universe since moments after the Big Bang. The LHC's primary mission involves exploring fundamental physics through these extreme energy collisions, most famously leading to the discovery of the Higgs boson in 2012, which confirmed how particles acquire mass. The collider features 4 main crossing points where accelerated particles collide, surrounded by massive detectors like ATLAS and CMS that track the spray of particles created in these violent encounters. These detectors, built like giant 3-dimensional cameras made of millions of sensors, can capture the fleeting signatures of exotic particles that exist for mere fractions of a second.
The theory behind microscopic black holes.
The possibility of creating microscopic black holes at the LHC emerges from revolutionary theories involving extraspatial dimensions beyond our familiar 3. Models proposed by physicists Nima Arkani Hamed, Savas Dimopoulos, and Gia Dvali, known as the ADD model, suggest that gravity might propagate through additional hidden dimensions, while other forces remain confined to our 3-dimensional space. These theories attempt to solve the hierarchy problem, why gravity appears so much weaker than other fundamental forces. A tiny refrigerator magnet can overcome Earth's entire gravitational pull, suggesting gravity's apparent weakness might result from it spreading through extra dimensions we cannot perceive. If these extra dimensions exist, they would dramatically lower the energy required to create black holes from an impossible 10 to the 19th giga-electron-volts down to potentially just a few tera-electron-volts. Precisely the energy range the LHC can achieve. Under these conditions, when protons collide at nearly light speed, they could concentrate enough energy within a tiny region to exceed the Schwarzschild radius, causing spacetime to collapse into a microscopic black hole. According to Stephen Hawking's theory, such micro-black holes would be extraordinarily unstable, evaporating almost instantly through quantum radiation in roughly 10 to the minus 27 seconds while releasing distinctive particle signatures.
The hunt for quantum black holes.
The CMS and ATLAS experiments at CERN have conducted extensive searches for microscopic black hole signatures in proton-proton collisions. These searches focus on identifying the distinctive particle sprays that would result from Hawking radiation as micro-black holes evaporate almost instantaneously after formation. The CMS experiment completed comprehensive searches for microscopic black holes produced in high-energy collisions, analyzing data for the characteristic patterns these exotic objects would create. Their detectors look for events where particles converge inward rather than spray outward, consistent with space-time being warped by extreme gravity before the black hole's rapid evaporation. Recent ATLAS collaboration research published in 2023 searched for quantum black holes in electron plus jet and muon plus jet invariant mass spectra using 140 inverse femtobarns of collision data. While no definitive evidence was found, the experiment set important limits on black hole production, ruling out their existence below certain mass thresholds in various theoretical models. The search techniques involve sophisticated pattern recognition algorithms that can distinguish genuine black hole signatures from the background noise of ordinary particle collisions. These advanced analysis methods continue to push the boundaries of what's detectable, bringing scientists closer to potentially revolutionary discoveries.
Hawking radiation and instant evaporation.
Stephen Hawking's groundbreaking 1974 theory predicted that black holes aren't completely black but actually emit radiation due to quantum effects near their event horizons. This process, which we call Hawking radiation, happens when quantum fluctuations create particle-antiparticle pairs right at the black hole's boundary. One particle falls in, while the other escapes. Now, for microscopic black holes, this evaporation process happens almost instantaneously. The smaller the black hole, the more intense its Hawking radiation and the faster it evaporates. A micro-black hole created at the LHC would exist for about 10 to the minus 27th seconds, an almost incomprehensibly brief moment during which light can barely travel the width of a single proton. During this fleeting existence, the black hole would release its entire mass energy as a burst of particles, creating a distinctive signature that, in principle, sophisticated detectors could potentially observe. The evaporation would produce a specific spectrum of particles including quarks, gluons, photons, and possibly even some exotic particles not found in the standard model. This rapid evaporation ensures that any micro-black holes created at CERN would be completely harmless, disappearing long before they could interact with surrounding matter or, grow larger through accretion.
Evidence for extra dimensions.
The detection of micro-black holes would provide, honestly, the first experimental evidence for extraspatial dimensions, fundamentally revolutionizing our understanding of reality's structure. The Arkani-Hamed-Dimopoulos-Dvali model and Randall-Sundrum scenarios propose that our universe contains additional spatial dimensions beyond the three we experience directly. These hidden dimensions would be compactified, curled up so tightly at every point in space that we just can't perceive them in everyday life. Imagine for a second an ant walking along a garden hose. From far away the hose looks one-dimensional, but up close, the ant can move around its circumference through an extra spatial dimension. If gravity propagates through these extra dimensions while electromagnetic weak and strong forces remain confined to our familiar three-dimensional space, it would explain why gravity appears so much weaker than the other fundamental forces. The precise energy threshold for micro-black hole production would actually reveal the number and size of these extra dimensions. Recent theoretical work suggests that observing micro-black hole evaporation patterns could provide detailed information about the geometry of extra dimensions, potentially mapping aspects of reality that have remained hidden since the universe's beginning. This would represent, without exaggeration, one of the most profound discoveries in the history of physics.
The search continues with advanced technology.
CERN's search for micro-black holes employs, honestly, some of the most cutting-edge detection technology and analysis techniques that really push the boundaries of experimental physics. The ATLAS and CMS detectors surrounding collision points contain millions of sensors arranged in layers, creating three-dimensional snapshots of particle interactions with unprecedented precision. Machine learning algorithms now analyze collision data, searching for subtle patterns that might indicate micro-black hole formation and evaporation. These AI systems can process vast amounts of data far more efficiently than human researchers, identifying anomalies that might otherwise be missed in the background noise of ordinary particle collisions. The CMS experiment's search for microscopic black holes has set increasingly stringent limits on their production, ruling out their existence up to masses of 3.5 to 4.5 TeV in various theoretical models. Similarly, ATLAS collaboration research has pushed these limits even higher, with recent studies excluding quantum black holes below 9.2 TeV in the ADD model and 6.8 TeV in the Randall-Sundrum model. As the LHC undergoes upgrades toward its high-luminosity phase, planned to begin operations in the late 2020s, the increased collision rate and improved detector sensitivity will provide even more opportunities to search for these elusive quantum phenomena.
Connections to dark matter and dark energy.
The potential discovery of micro-black holes at CERN could, really illuminate the mysterious dark sector of physics which actually makes up about 95% of the universe's content. Dark matter and dark energy are still, among the greatest unsolved puzzles in cosmology, and we can only detect them through their gravitational effects on visible matter and the expansion of the cosmos. Some theoretical models even suggest that black hole evaporation might produce particles from the dark sector, which would offer us a unique laboratory window into these invisible components of the universe. If micro-black holes briefly connect our familiar matter with dark matter through quantum effects, then their evaporation signatures could finally reveal the nature of particles that have managed to elude direct detection for decades. Now, primordial black hole theories propose that tiny black holes formed in the early universe could account for some or maybe even all of dark matter. If CERN's experiments are able to produce micro-black holes with evaporation patterns that match theoretical predictions for primordial black holes, that would be honestly pretty compelling evidence for these cosmological models. Additionally, some theories suggest that dark energy's mysterious acceleration of cosmic expansion might be connected to extra dimensions through which gravity propagates. So, micro-black hole production could, in fact, offer indirect evidence for these connections, potentially solving multiple cosmic mysteries at once through a single experimental breakthrough.
Quantum entanglement and space-time connections.
The creation and evaporation of micro-black holes provides a unique testing ground for the revolutionary ER equals EPR conjecture, which was proposed by physicists Juan Maldacena and Leonard Susskind back in 2013. This groundbreaking idea suggests that quantum entanglement and wormholes, also known as Einstein-Rosen bridges, are actually the same phenomenon, just viewed from different perspectives. According to this theory, when particles become quantum entangled, they're actually connected through these tiny wormholes in the fabric of space-time itself. If micro-black holes form at CERN, their evaporation could produce entangled particles that reveal these quantum connections, potentially providing the first experimental evidence for this profound relationship between quantum mechanics and general relativity. Observing correlated particle decays from micro-black hole evaporation could demonstrate that space-time isn't really the fundamental backdrop against which physics happens, but rather something that emerges from deeper quantum information relationships. This would suggest that the fabric of reality is woven from quantum threads of information, instead of being a smooth, continuous medium. Discoveries like this could address the black hole information paradox, which is this really fundamental problem where quantum mechanics and general relativity seem totally incompatible at black hole boundaries. The data from micro-black hole evaporation might finally reveal whether information falling into black holes is truly lost, or somehow preserved in their radiation. Safety and cosmic ray comparisons. Concerns about creating black holes at the LHC have been thoroughly addressed through comprehensive safety assessments by independent groups of physicists all over the world. The fundamental argument for safety comes from comparing LHC energies with natural cosmic ray collisions that constantly bombard Earth's atmosphere. Cosmic rays from space carry energies up to 10 to the power of 20 electron volts, which is about 10 million times higher than the LHC's maximum energy of 13 tera-electron volts. These ultra-high energy particles create natural collisions with our atmosphere roughly 1 million times per square kilometer every year, and Earth has experienced this kind of bombardment throughout its 4.5 billion year history without any damage at all. If micro-black holes could pose any danger at the energies CERN explores, nature would have already conducted these experiments countless times throughout cosmic history. The fact that Earth and other astronomical objects remain completely intact demonstrates that such phenomena are either impossible or totally harmless. Even if micro-black holes formed but didn't evaporate through Hawking radiation, which would mean Hawking's theory is fundamentally wrong, they would still pose no threat, thanks to their incredibly weak interaction with ordinary matter. They would just pass right through Earth almost without effect, similar to the trillions of neutrinos that pass through our bodies every second, unnoticed. The future of fundamental physics. The potential discovery of micro-black holes at CERN represents a lot more than just confirming some exotic theoretical predictions. It would actually mark the beginning of a whole new era in fundamental physics research. Such discoveries would provide the first experimental access to quantum gravity, the long-sought theory that unifies quantum mechanics with Einstein's general relativity. Understanding how gravity behaves at quantum scales could, honestly, revolutionize technology in ways we can barely even imagine, maybe leading to new forms of energy generation, propulsion systems, or even manipulation of space-time itself. The knowledge gained from studying micro-black hole evaporation could also inform our understanding of the universe's earliest moments, as well as its ultimate fate. As CERN prepares for the high-luminosity LHC upgrade and looks ahead to even more powerful future colliders, the search for micro-black holes will continue with unprecedented sensitivity and precision. Every single collision brings us closer to potentially revolutionary discoveries that could reshape our understanding of reality's most fundamental nature. The journey into quantum gravity and extra dimensions is humanity's boldest exploration of the cosmos, probing the deepest mysteries of existence through the power of human ingenuity and international scientific collaboration. Whether or not micro-black holes actually exist, the search itself advances our knowledge of the universe's most profound secrets. CERN's quest to create and study micro-black holes really does represent humanity's boldest attempt to understand the fundamental nature of reality itself. Whether these quantum phenomena exist or not, the search has already pushed forward our knowledge of particle physics, extra dimensions, and those deep connections between quantum mechanics and gravity. As scientists keep pushing the boundaries of what's possible, We're standing on the threshold of discoveries that could transform our understanding of space, time, and matter forever. Thanks for watching Stellar Tech, and don't forget to subscribe for more groundbreaking discoveries from the frontiers of science.